The web shooter is one of those ideas that sounds ridiculous, until you think about it for more than 10 seconds. A tiny device on your wrist, you flick your fingers, and suddenly you're flying between skyscrapers like gravity just gave up on you. That's insane, and yet somehow, Spider-Man makes it feel normal. Out of every superhero gadget ever created, the web shooter stands out. And this isn't because it's loud, flashy, or because it can explode. It's just clever. So clever that for years, people have been asking the same question. What's actually inside that thing? How does it work? And more importantly, could something like this exist in real life? In the Marvel Cinematic Universe, Peter Parker's web shooters exist in two major phases. The first is Peter's homemade version. The second is the upgraded system designed by Tony Stark. While the Stark version is far more advanced, both are built on the same core principles: compact engineering, precision control, and an understanding of materials far beyond what a normal teenager should possess. Let's start with the physical structure. Tom Holland's web shooters are wrist-mounted devices, built to sit just below the palm. This position is important. It allows the web to fire in alignment with the hand, making aiming intuitive and reducing strain on the wrist. The casing is slim, durable, and designed to withstand extreme forces like impacts, rapid motion, heat, friction, and repeated mechanical stress. Inside that casing is where the real magic happens. At the heart of the web shooter is the web cartridge system. Unlike Tobey Maguire's biological webs, Tom Holland's Spider-Man relies entirely on technology. Each shooter contains replaceable cartridges filled with synthetic web fluid. These cartridges are small, but incredibly dense. Each one holds hundreds of meters of webbing, compressed under immense pressure. The web fluid itself starts in a liquid state. It has to. A solid thread couldn't be stored in that volume, nor could it be expelled at high speed. The fluid is engineered to remain stable while compressed, but react instantly when exposed to air and specific mechanical forces. This reaction is the key to everything. Attached to the cartridge is an electromechanical valve system. This valve is normally sealed shut, preventing accidental discharge. When activated, it opens for fractions of a second, releasing a controlled burst of web fluid. The timing here is critical. Too long, and the web floods out uncontrollably. Too short, and the thread snaps or fails to anchor. Controlling this valve is a miniature onboard computer. Inside Tom Holland's web shooters is a microcontroller, far more advanced than anything Peter built on his own. This was Tony Stark's contribution. The microcontroller receives input from the trigger mechanism, processes the request, and determines how the web should be deployed. This includes pressure regulation, web type selection, and safety limits. Yes, safety limits. The shooter actively prevents dangerous misfires, overloads, or structural failures. If the system detects a fault, it can lock itself, redirect output, or shut down entirely. This is why Peter can survive situations where a lesser-built device would explode on the wrist. Now let's talk about the trigger. Tom Holland's Spider-Man fires his web using a gesture-based trigger system built into the glove. When Peter presses his middle and ring fingers into his palm, conductive pads close a circuit. This sends a signal to the microcontroller, confirming intentional activation. This design is brilliant for one reason. It prevents accidental firing. Open hands, relaxed movement, or combat impacts won't trigger the web shooter. Only a deliberate finger press will. This allows Spider-Man to move naturally without constantly spraying webbing everywhere. Once the signal is received, the system moves fast, almost instantly. The microcontroller opens the valve. Pressurized web fluid rushes forward into the nozzle assembly. This nozzle is not just a hole, it's a shaping mechanism. Inside are microchannels that stretch, twist, and align the polymer chains in the fluid as it exits. This process mimics how real spider silk is formed. As the fluid passes through the nozzle and hits open air, it undergoes rapid polymerization. In simple terms, it hardens, but not into something brittle. It becomes a strong, flexible, elastic thread capable of absorbing massive forces. Within milliseconds, the web goes from liquid to solid. That's why Spider-Man can instantly stick to walls and eat raw meat. Stick to walls and grab moving objects or swing between buildings. The web doesn't need time to set. It's ready the moment it leaves the shooter. Powering all of this is a compact energy system. The web shooters use high-density lithium-based batteries, similar in principle to those found in smartphones or smartwatches, but far more efficient. These batteries power the microcontroller, valve motors, sensors, and communication systems. They are designed to last for extended periods while remaining small enough to fit inside the wrist unit. Now, here's where Tom Holland's web shooters truly stand apart from every other version. The Stark upgrade. Once Tony Stark steps in, the web shooters become more than mechanical devices. They become smart systems. Integrated with the Spider-Man suit, the shooters are now connected to an onboard artificial intelligence. This AI monitors Peter's movements, surroundings, and intentions. That's how multiple web modes exist. Each mode changes how the web is expelled, structured, and anchored. The AI adjusts pressure, viscosity, nozzle geometry, and firing pattern in real time. Peter doesn't need to manually reconfigure anything. A thought, a gesture, or a verbal command is enough. The AI also assists with aiming. While Peter has enhanced reflexes, the system subtly adjusts firing angles to compensate for movement, wind, distance, and target speed. This turns every shot into a calculated decision, even in chaotic combat. But the most impressive part isn't the tech, it's the restraint. Despite having access to incredibly powerful web modes, the system limits lethal force. The web shooter is designed primarily for capture, restraint, and mobility. This reflects Peter Parker's core philosophy. Power exists, but it must be controlled. Now that we've known all that, could something like this exist in real life? Well, surprisingly, yes. Miniature valves, microcontrollers, pressure systems, gesture-based triggers, and compact batteries already exist. Engineers and hobbyists have built functional wrist-mounted launchers using compressed air or CO2. From a mechanical standpoint, the web shooter is not impossible. The real problem is the web. Natural spider silk is one of the most remarkable materials on Earth. It's stronger than steel by weight, lighter than plastic, incredibly elastic, and capable of absorbing massive energy without snapping. No human-made fiber fully matches all of its properties at once, and harvesting it isn't practical. Most spiders don't live in colonies. They're territorial, aggressive, and often cannibalistic. Farming them at scale is nearly impossible. Even when silk is collected, the quantities are tiny. That's why real-world scientists focus on synthetic spider silk. By replicating the spidroin proteins responsible for silk's strength, researchers have created fibers that come close to the real thing. Some are produced using genetically modified bacteria, plants, or even goats. These synthetic silks are already being tested for medical sutures, body armor, and aerospace materials. But even if we had perfect web fluid, swinging like Spider-Man still wouldn't work. The forces involved are extreme. Every swing generates massive G-forces on the arms, shoulders, and spine. Peter Parker can survive this because his muscles are superhuman and his bones are reinforced. A normal human would suffer dislocations, fractures, or worse after just one swing. Our bodies simply aren't built for it. However, the technology wouldn't be useless. Web-like materials could revolutionize safety equipment, construction, rescue operations, and even space exploration. Ultra-strong cables, rapid deployment restraints, lightweight armor, temporary structural supports. The web shooter isn't fantasy. It's a vision of what happens when intelligence, creativity, and responsibility meet advanced engineering. And that's the real point. Spider-Man's strength was never just his webs, or his suit, or his powers. It was his mind. His ability to learn, adapt, and choose to do the right thing, even when it's hard. The web shooter is just a tool. What truly makes Spider-Man special is the person behind it. And that's why the most fascinating version of Spider-Man might not be the one with the smartest tech, but the one who never needed it at all. Tobey Maguire's Spider-Man. A Spider-Man whose webs weren't built, upgraded, or replaced, but grown. Once we really break down how those biological webs would work, it stops being cool and starts being a bit disturbing. But that's a shocking story for another time.